Okay, so I want to show you how to set up this low pass filter thing here. The first thing you do, you establish the time frame. So time here, and then you start with time 0 and go up like 0.1 seconds at a time. So all you got to do, mark these two cells, pull them down until you are around about 6 seconds is what you need here. So you have all these numbers, and the next thing you generate is the input signal. You call this input, and you're starting at 0, 0, 0, pull it all the way down to probably 1 second, and everything that's after 1 second is a 1. So that's our step input. So the signal makes a step from 0 to 1, and it does that at exactly a time of 1 second. So what we're going to do, let's take a look at this, how this looks in a graph. So what you do is you mark all these, you start with insert and then an XY graph. It's those. Don't take the line, don't take the bar graphs, take the XY point graphs. You go right click, select data. And click on the plus. So you want to give it a name. The name of that data is the input. The X values are the time. It's this one. And the Y values are the input signal. Okay. So you're getting a little graph. Let's blow this up a little. Like this, that's your input signal. The input signal is 0, 0, 0 all the way, and then when time 1 second shows up, boom, it jumps up to 1. There's nothing in between. It's a step. It's not a very, very, very steep gradient. It's a step, period. So it goes to 1 and it stays at 1. So we're interested, how does the filter respond to this? And we want to make a low-pass filter. So we're generating an output signal. So this is the input signal, and just to make it clearer, make it all the way, I'll make it blue, a very pale blue, and then the signal that comes out of the filter, let's make it very pale green so that we can clearly distinguish the two, and that's the output. So let's create that output. What we're doing initially, it's really, really simple. The output is equal to the input. That's it. So it's an equal sign. Initially, it's always the same. It's identical. So what we do from then on is for every next time step, for every point in time, we generate that output by taking an average basically between the new input and the old output. So we can't really choose. We have two hearts beating in our chest. We want to make the output stay where it is because we want to dampen it, but we also want to let it go to where it wants to go, to the new input. So let's make this an average, and not just a middle average, but a weighted average. So we're doing equal sign. So it is the input multiplied by, let's say, 5%. And then we add the previous output. So it's, I'll put this here. So plus this cell multiplied by 95%. So we're creating a weighted average, so to speak. We're giving 5% of weight to the new input, which is here, and 95% of weight to that old output. That's what we want to keep. So when we enter this, of course, it's still 0 because the input is still 0. But let's take that cell and then drag it all the way down, extend it until we are here at the 6 second mark. Whoops. And you will see that, of course, initially it's all zeros. It doesn't do anything because you can multiply 0 by anything you want. It'll stay 0. But as soon as that input signal jumps to 1, the output signal will start to react. And because we gave it this 5% step size, of course, it's 0.05. That's what 5% is. So the first frame, really simple. But the second frame, well, now it takes the average between the previous and the 1. So it's not quite a 0.05 units of a step. So it's a bit of a smaller step. And if you look at the numbers here, you get crazy. So let's not look at the numbers. Instead, let's look at the graph. So what we could do, we mark this thing. We go Control Copy, Control Paste, or Control Z. And then we have that exact same thing again here. Let's grab the data for it and move it over here. So what we want is this. So the orange is our input and the blue one is our output. Let's change that for a second. Okay, so I just changed the color of the graph. The input signal is blue, the output signal is green. And what we did is, like, step by step, we allowed every new output value to be composed of the previous output and the new input. So this cell is being created by the mixture of this, and we gave it a weight of, in this case, 5%. You see the numbers build up, and that's what you see here. You see initially the green line stays 0, 0, 0 all the way, because 0 always stays 0. The filter is in what I would call an equilibrium state. There's no difference between where it is and where it's supposed to be. But as soon as the input jumps up to 1, that output wants to go to 1. And it's kind of always aiming towards that line, but it'll never quite reach it. And in fact, if you continue this forever and you check a bunch of decibels, a bunch of digits after the decimal, you would see that it would never really reach it, but eventually it goes so close that it really doesn't make a difference. So that's, in a nutshell, a low-pass filter, and the implications of it will become clear as soon as we start playing around with it, and I'm going to show you that in another video. Just for now, if you want to follow along, just make sure you enter a certain time step scale, so to speak, like the time from 0 to 6 seconds. The input is all the way 0, and at some point it jumps to 1, and the output is always composed of a mixture between the previous output and the new input. And here's the formula. Take the new input times 5% plus the old output times 95%. And we're going to start to manipulate those values in the next video, and you're going to see, if you play around with these numbers, it'll become totally apparent and clear, totally self-evident what a low-pass filter is doing, what it can and what it can't do, and how it will influence the signal. So thanks for watching, take care, and yeah, keep enjoying this.